I welcome you all for this session, and I'm Dhanasekaran, Assistant Professor, Department of ECE. Today we're going to see CAN bus in embedded system subject. Okay, so first is control area network bus, that is CAN. Okay, so CAN is an important embedded protocol. So it's earlier it comes for automotive, but used in many other places. So CAN specify a physical layer, protocol layer, message filtering layer with add-on protocols. So you just note that CAN, how message periodization is achieved, and how small nodes can be kept from the overloading with the received message. Okay, so here we communicate information from one device to another device. So in between the CAN used to communicate the nodes. Okay, so it helps the communication between the nodes. Okay, so how the CAN developed. Okay, so we can see that the development of CAN began when more and more electronic devices were implemented into a modern motor vehicles. For example, such device includes engine management system, active suspension, ABS, that is anti-braking system, gear control, lightning control, air conditioning, airbags, and central locking. So you know that, right? And to improve the behavior of vehicle even further, it was necessary for the different control systems and their sensor to exchange the information. So sensor can give some information to the controller for controlling that particular device, right? So this was usually done by discrete interconnection of different systems, that is point to point wiring. So if you want to connect with the node, you can connect with point to point wiring. So here what can do is, so can replace the point to point connection. Okay, so it uses the bus for communicating information from one node to another node. The requirement of information exchange has been grown to such an extent that cable with a length of up to several miles, so and many connector was required. So if you connect the several miles or several distance, you need many connectors. Okay, so for to communicate with each node, this is produced growing problems and concerning material cost and production time and reliability. Okay, so you can see this diagram, it clearly you can justify it. Okay, so what's the problem here? Here we have a dashboard and anti-braking, engine control, everything connected. So there is a collision here, you can easily notify it. Okay, so with the CAN, so what we can do with the CAN, so we can connect the each nodes. Okay, so the solution to this problem was the connection of the control system via serial bus. Here we can use serial bus. With the use of CAN, the point to point wiring is replaced by one serial bus connecting all control systems. So this is accomplished by adding some CAN specific hardware to each control unit that provides rules or the protocol for transmitting and receiving information via bus. Here you can see the dashboard, and you can see the connections, that is engine control, transmission control, active suspension, anti-lock brakes, and here lightning, power states. And left side you can see the high speed connection, and the right side you can see the low speed. That is every message having some priority. Okay, so through that the priority we can identify which one is important and which one is less important, that is most important and less important. By the way we identify that a message is high priority and low priority. See the CAN bus protocast type of bus. CAN is a protocast type of bus. What is protocast? So this means that all node can hear all transmission. So there is no way to send the message to a just a specific node. So all node is invariably pick up all traffic. The CAN hardware, however, provides local filtering so that each node may react only on the interesting message. See, In the image you can see that the multi-master concept, number of nodes not limited by the protocol, and no node addressing message identifier specify the content and the priority. So here node A and node N, okay, up to node N the CAN bus through connect through the logical, okay. So each connection disconnection of nodes and broadcast and multicast capability, okay. So this is the configuration of CAN. So you can see the application, host control, CAN transmitter. So here node A and up to the node N, okay. This is the configuration. And here in the bottom they mentioned that 40 meter, that is 130 feet up to 1 Mbps speed, okay. So this is the CAN bus overview. The basic physical layer uses a different transmission on the twisted pair wire. So the buses uses non-return to 0 with bit stuffing. There is a bit stuffing which is used to find out the logical, that is 1 or 0. The bit stuffing is used for the arbitration. The arbitration means that control the broadcasting, that is if each node, that is the same time the two nodes broadcasting the information, so that time we create some problem. So that arbitration will control the CAN bus through the transmitting of node information, okay. The maximum transfer rate is 1000 kilobits per second at the minimum bus length of 40 meters and 130 feet, that is a 40 meter or 130 feet when using the twisted pair, which is most common bus medium of CAN, okay. The message length is start with a maximum of 8 data byte per message, and we are here they use cyclic redundancy chip, that is for error checking. And the bus is handled via the advanced serial communication protocol, carries sends multiple access collision detection, and here the non-destructive arbitration is used. So this means the collision message avoided by the bitwise arbitration without loss of time. So if the two node access the same time, that time we need arbitration. So arbitration will clear the messages which based on the priority. So every message having some identifier which has some priority. There are no explicit address in the message. Instead of each message carries some numerical value which controls the priority on the bus. And you can see that is basic bit encoding, that is we here bit stuffing relaxes accelerate the diff requirements. Here we used that bit stuffing. So in this you can see that the sixth contiguous one, that is here we stuff the opposite bit stuffed in this stream. If it is 1 you can stuff it into a 0, if it is 0, if it is stuffed into a 1, okay. This is the CAN bus characteristics. Here logic 1 and logic 0 is, the 1 is the recessive bit and 0 is dominant, and recessive bits is a default in the CAN bus. If it is an dominant bit means it's, if it is any, as soon as the one node transmits a dominant bits, bus in the dominant state. If only if all node transmit a recessive bits means the bus in recessive state. So here we have a dominant state and the recessive state. And see the characteristics of wired, and so you know that if it is in a one dominant means the bus will dominant state. If it is an all recessive bit means then only it will be a resistive state, okay. And here the bus access arbitration in carry sense multiplexes, collision detection, and non destructive arbitration, that is the loses that arbitration, that here you can see the images, B loses the arbitration and C loses the arbitration. This is the bus transmission speed. So they mentioned here bit rate and here the CAN bus length. Okay, you can see that the maximum speed is 2 into t, that is a t is the proper propagation delay of the electrical medium. Propagation delay means when the input is reached to the output, so how it will take, how much time it will take, that is a propagation delay. And CAN protocols, we have flow control, transmission of data, nodes address, and establishment of communication next. So higher layer protocol, that is standardized startup procedure, distribute the address bus, determine the layout for the messages, and some higher layer protocols, device net and CAN kingdom, CAN open. So CAN standard, we have defines of 4 messages, that is data frame, remote frame, and error frame, and overload frame. So the message uses the clever scheme bit stream arbitration to control the access to a bus, and each message stacked with the priority. So CAN standard defines elaborate scheme for the error handling and confinement. CAN may be implemented using the different physical layers, and there is also a number of different connectors in the use. So this is the uh, bit fields of standard CAN. So starting with startup frame, identifier, RTR, and IDE and R0, and DLC, that's a, and bytes data, and cyclic redundancy check, acknowledgement and enter frame, that is IFS, then the last. Okay, so RTE mean RTR means remote transmission request, and ID means identifier extension. So no being it's says that ID no extension is being transmitted. And DLC means the data length code, number of bytes data being transmitted. And in the bit fields of standard CAN, data up to 64 bits of application data may be transmitted. In the cyclic redundancy check contains this checksum and the number of bits transmitted for proceeding the application. Data for an error detection, the acknowledgement, every node receiving an accurate message overrides this receive bit, the original message with the dominant bit, so indicating an error free messages has been sent. Okay, so overall the CAN bus is used for replacing point to point wire communication, and especially it's for automotive, and we can connect more and more device using CAN bus controller. So that is a very uh, basic application. And thank you all for watching.